This is our second lesson on Riemann sums. Okay, it's quite a heavy topic. So what we just learned last lesson is to find, what is the Riemann sum? Riemann sum is an estimate of the area under a curve. And it's basically what you've got to do is find the width of each block, which is b minus a over n. A and b are boundaries. Okay? And then you sum the values of xi. Okay? Now, to be able to calculate Riemann sums, we're leaving integration for a bit. We'll come back to it towards the end of this lesson, maybe even next. We'll see. But we're leaving it. Okay? Riemann sums, just sums. 1 plus 2 plus 3. We're just calculating sums. Okay? To be able to evaluate, to calculate these sums, I need a bunch of formulas. Okay? You'll see why in a second. So the first formula is very, very clear. Okay? So I've got a sum of, I've got 1, okay? And I'm adding 1 n times, right? This thing tells you the index runs from I equal from 1 to n, but all I'm adding is just 1. I don't have the letter I here. So this thing really means, okay, it's 1 plus 1 plus 1 plus 1 plus, how many times do I add this 1? N times, because the index always go from I equal 1 to I equal 2, 3, 4. So I'm adding 1 n times. Obviously, the answer will be n. So that's just obvious. Okay, we can figure it out very easy. The next formula I can prove to you, a little bit more difficult, but not that hard. Okay, here I'm adding again n time, but I'm not adding 1, the number 1 n time. I'm adding the index himself. So when the index, well, I equal 1, I'm just doing 1. Then index just keeps on the slide going. 1, 2, 3, just goes up. So next thing, index the I become 2, so I need to add 2. Okay? Then I equal 3, so I need to add 3. Because you see I've got I inside here. So 1 plus 2 plus 3 plus da 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 da. What's the final one? N. Okay? Now you know how to evaluate a sum like that, right? That's what you call a linear sequence, arithmetic sequence. One of the ways to evaluate is to take the first term, the last term, divided by 2, and we're timing it. Am I doing that right? First term, second term, divided by 2, and timing it by the number of terms. So the answer is time n. Okay? So how much is that? Is n over 2 plus n squared over 2. So that's where this formula comes from. Okay? We'll be alright with that. Okay? Alright? So again, maybe just to kind of explain what this formula means. Okay? If n is, let's say, I've divided the block into 10. Okay? 10 blocks. So if I need to add I 10 times, it's just going to be 10 squared divided by 2 plus 10 over 2. You'll see how we use these formulas in a minute. The other two, okay, when I'm summing I squared and I cubed, at this point we are not able to prove them, but we will prove them next year with a wonderful tool called induction. Really, really, one of the best things about AP is that you're learning induction. It's really beautiful. Okay, so we're going to leave those to grade 12. Okay, let's pause here. Okay, so now we're going to use all this information to solve a problem. What is a problem? Calculating a Riemann sum. So they'll give you a function. Obviously, we're working with some kind of function, x squared plus 3. They'll give you the boundaries, x equal minus 2 and x equal 3. So a is minus 2, b is 3. And I've divided into 12 blocks. Okay? So we are basically, what we're trying to do, what is this Riemann sum? Is an estimate to the area under this curve, okay, if I use 12 rectangles, okay, between minus 2 and 3. So the first step is to count, look what I've got here. What do I have here in this Riemann sum? I've got b minus a over n, and I've got f of xi, and then I've got to sum it. So the first thing I need to find the b minus a over n. That's the width of the block. So b minus a over n is 3 minus 2. You always want to do the largest boundary before. So you'll get a positive number divided by 12. 5 over 12. Am I right? I'm just checking. Yes, 5 over 12. So that's the width. Next thing is the height. Okay, well, the height changes. The height, that's the height. It depends on the value of x. So to know the height, first of all, I'm going to get the formula for xi. Okay, so xi obviously is xi squared, sorry, just a second. Okay, xi, I should have, just let me pause here, I'll write down the formula. Okay, so that's one more formula that I've missed, and you need to know it, and it's over here. Okay, value of xi, we developed it last lesson, is the first boundary, a, plus I, the index, times the width of each block. So it basically tells you it's A plus the number of width of block. For the first one is 1, for the second one is 2, and so on and so on and so on. So we need to find out. Okay, so A, for this specific thing, so A is equal minus 2. Okay, I is a number, so I mean it's a variable, so I'll leave it like that. And B minus A over N is basically your width, so it's 5i over 12. So minus 2 plus 5i over 12. Okay, so that's not what we wanted to find out. We want to find the height. Okay, the height is f of x of I, f of xi. So now, if this is xi, I need to substitute inside x here. So f of x of I will be minus 2 plus 5i over 12. Now, don't be confused, well, that's obviously squared, squared, plus 3. Okay? So I'm squaring all this monster, plus 3. Now, don't get confused here. I is not your imaginary number. It's not I squared equal minus 1. I is just the variables, like x. Okay? So now I need to do this mess. Okay. So minus 2 squared is 4. Okay? Minus 2 is 4. Okay, I'll just write it down like that. So minus 4 times 5 over 12i plus 25i squared over 144. Okay, let me just check that I've done it right. Okay, and indeed I did forget the plus 3. Okay, I forgot about the plus 3. So now adding all together, what I'm going to get, f of xi is 7, and that's 1, 3, so minus 5i over 3 plus 25i squared over 144. Okay, so we got the width of each block, we got the height. Now I'm in a position to actually calculate the sum. Okay, I will need to make some space, so don't go away. Okay, we'll carry on at the bottom. It's important for me you guys see all the steps. I might have to erase something later, but I just wanted you to see the steps. So after, first of all, I found the width of the block. Then I found the height of the block. But to find the height of the block, first of all, I have to find out what is the x equal to, xi. Okay? And then I put it into the function, I get the height of the block. Now I'm going to sum it all, okay? So how am I going to sum using that formula? So I've got, I need to write down the width, okay? The width is going to be 5 over 12 times sigma, okay? I runs from 1, okay? How many blocks do I have? N equal 12. So from 1 to 12, and inside here I'm going to put now the heights, okay? It's going to be 7 minus 5i over 3 plus 25i squared. I squared is not minus 1, okay? It's not the imaginary number, okay? All that big business is inside that sum, okay? This is it, okay? Alright? Now, why did I write a squiggly equal, okay? Squiggly equal sign, not the equal sign, squiggly equal, because the area is not equal to that, okay? It's just an estimate of the area. We said the higher n is, the more accurate it will be, but it's not equal. Okay, now I just want to make sure I've written it all nicely. Yes, I'll just pause here, okay, so you can see the steps. Step 1, finding width. Step 2, finding the height. Step 3, summing all together. We're not finished. We need to get actual number, okay, but now I'm just going to have to clear out to make some space, so hang on. Okay, so I'm trying to calculate this bit, okay, and the way I'll do it, instead of writing 5 over 12 times the sum of this, and then I equal 2. Put 2 here. Then put I equal 3. Put there. What I can do is say that's going to be equal to sum each one of these terms separately. Instead of summing all this term from 1 to 12, I'm going to sum this from 1 to 12, this from 1 to 12, this sum to 1 to 12. So I'm going to write down the area as, okay, 5 5 over 12 times, with brackets, I equal 1 over 12 of 7 minus I equal 1 to 12, 5I over 3, plus I over 1 to 12, all right, 25I squared divided by 144. See, I'm just split into this sum, okay? Now, why did I do that? Because each one of these sums, I can now use these formula to calculate it. So each one of these formula give me a certain sum with either I or I square or I cube, or no I at all. So let's try and use it. Let's use it. Okay, so I'm going to have 5 over 12. What's written here? Okay, this is 7 plus 7 plus 7 plus 7, 12 times. Okay, yeah, I don't even need to use that. I mean, I know this is n, so I should really write 12 times 7, but that kind of makes sense. I've added 7 to itself, and added 7 12 times. Okay, so that's not a problem. Next one, I've got 5I over 3. Well, I don't have anything with 5I over 3 inside the sum. But think about it, that 5I over 3, it's like 5 over 3 times I. I'll just write it down here. This is 5 over 3 times 1 plus 5 over 3 times 2 plus 5 over 3 times 3 plus blah 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 blah. So I'm always multiplying 5 over 3 by the I. So I can get the 5 over 3 outside of the summing sign. If I have a constant that I multiply by my variable I all the time, okay, I can take it as a common factor. So I can write that as 5 over 3 and write down I equal 1 to 12 and put the I here. Why is that good? Because now this business, I know how to calculate using that. Okay? So I want to get out from inside the summing. I want to get anything else and just leave either. All the constant numbers will come out. Okay? Right. So I'll do the same here. Okay? Now I've got I squared and a bunch of numbers which just repeat themselves. That's a constant. That's always going to be time I squared. So I can get it up. I'm going to write 25 over 144 sigma I equal 1 to 12. To n, I know what that is. I squared. Okay? Voila. Okay? And now I'm finally in a position to apply these formulas. Okay? So I'm going to have 5 over 12 times, what is 12 over times 7? 84. Okay, I'm copying from there. Okay? Minus 5 over 3 times, what is sigma I from 1 to 12? I just use that formula. Okay? Sigma I from 1 to 12 is going to be, instead of n, I'm going to put 12. Okay? Because now I know what the n is. So I'm going to write down 12 squared divided by 2 plus 12. Okay, so here I've got a specific n. So I put it, instead of n 12, I'll get 12 squared over 2 plus 12. 12 over 2. Okay? That's this one. Now here I've got 25 over 144. And I need to multiply by I sigma I squared, where n is equal to 12. Where do I have I squared? Over here. So I'm going to substitute, instead of n, I'm going to write 12. So I'm going to write 12 cubed over 3 plus 12 squared over 2 plus 12 over 6. Okay? And all that terrible, terrible thing, okay? I need to eventually add them all up, times by 5 over 12. Well, I'm not going to do that. Okay? You can just use a calculator. But the answers they're getting here in the book is 27,853. Okay? So the area to approximation of 12 blocks, the area under this curve between -2 and 3 with approximation of 12 blocks is going to be 27,853. Okay? Obviously that's not the accurate area, that's the estimate. And we've calculated our first Riemann sum. Now, it is tough, I'll agree with you. In fact, Riemann sum, which is, how should I say, is kind of a way to understand integrals. We'll see that in the next lesson. Riemann sum, in fact, is more difficult. To calculate Riemann sum is much more difficult to calculate integral. But it's the way mathematicians eventually realized and understood what they invented, you can say, integration. So we got to learn it. Sorry, guys. Okay, next video will be the final video, I hope, for Riemann sums.